Hey, it's Mr. Lineski with Unit 6, Section 4, Triangle Proportionality. We are still talking about triangles, we're still talking about ratios, and now we're going to solve for some x's here. So what exactly is triangle proportionality theorem? It basically states that if a line is parallel to one side of the triangle, then it divides the other two sides proportionally. So we have a triangle here with a line through it. If we know that this line is parallel to this line, we can set something up to say something along the lines of A is to B as C is to D. So it's saying that it's setting up the sides proportionally. So let's apply that over to here to solve for x. So knowing that these two lines are parallel, we have to have that. We have to have them marked parallel. We would say something like x is to 3 as 10 is to 4. Cross multiply just like we have been doing and solve for x. And when we solve for x, we get that x is equal to 7.5. As always, we have a converse. If you notice, that was an if-then statement. So the converse of triangle proportionality says that if a line divides two sides along a triangle proportionally, then we can state that those two sides are going to be parallel, that the parallel lines to the third side. So essentially we are asking, is DE parallel to BC? And so we're going to check that by checking, are the sides proportionate? Keep in mind, this is not the only way to set up the proportion. There's always tons of ways we can set up ratios and proportions. This is just the way that I like. So when I cross multiply here, what do I get? 10 times 24 is 240. 16 times 15 is also 240. So because these are equal, we absolutely can say that yes, DE is going to be parallel to BC. So those are parallel. So, unfortunately, triangle proportionality theorem cannot be used to solve for the parallel segments. Boo. However, we have another way of solving that, where we're going to set up what I call the small to big proportion. Sometimes you may hear me refer to this as the F method. Essentially, we're going to draw an F. So here, we have two variables. We have x and z. And if I wanted to solve for x, I know these lines are parallel, so I can set up my proportion and say 12 is to 6 as 15 is to x. And I can do that, and that's fine. And when I cross multiply, I get 12x is equal to 90. Solve for x, I get x is 7.5. But now when I go to solve for z, since z is on the parallel line, I am not allowed to set up a proportion like that, because this is what's causing the proportion to happen. So I can't say 12 is to 6 as 8 is to z. That doesn't make sense. So ideally, what you're looking at is you're going to be looking at two triangles. You're going to look at the small triangle, which is this one. And then you're going to look at the big triangle, which is this one. And you're going to compare them because we know that the two triangles are similar, because we have stuff like angle-angle similarity. And so instead, we're going to just compare side lengths. So I call this the F method because you end up drawing a little f. So we're going to say 12 is to 8. And then we're going to go along the big side. So this big side here is 12 plus 6. 12 plus 6 is 18, is to z. So anytime you're going along the parallel segment, that always means you're going to have to add two numbers together. So again, we can't say 12 is to 8 as 6 is to z, because 6 is just a little tiny segment, and we need it to be a part of a big segment here as part of the big triangle. So now, just like all the other problems, we're going to cross multiply and solve, and we get 12z is equal to 144. Multiply both sides by 12, and we get that z is 12. So just be careful. If you're solving for a parallel side, you got to use the F method and add. All right, so what happens if we have three parallel lines that are intersected by two transversals? Well, that just means that it also divides those up proportionally. So if I told you that L, M, and N were all parallel to each other, then we again would be able to say something like A is to B as C is to D. A is to B as C is to D. So on this problem here, 3 parallel lines cut by transversals. So, I turned it sideways. Don't let that fool you. We can still set up a proportion and say something like 3y is to 18 as 2 is to 4. Just make sure that you match sort of the order that you go in. Don't say 3y 18 and then 4 2. It's not the order you went in. Don't do that. So cross multiply, as always, we get something like 12y is equal to 36. Divide both sides by 12 and we get y is equal to 3. And the last thing we're going to look at is the triangle angle bisector theorem, which says if a ray bisects an angle of a triangle, bisect again means cut in half. So if we know we have an angle bisector, then that means that the ray divides the opposite side into 2 segments that are proportionate to 2 other sides in the same triangle in that order. What? Basically, it means if we have an angle bisector like we do here, that we can set something up such as A is to B as C is to D. And so in this problem here, when I ask you solve for x, we can say 20 is to 2x as 30 is to 4x minus 1. Cross multiply and solve. 2x times 30 is equal to 60x. 20 times 4x minus 1, remember we're distributing 20 to each of those, so that becomes 80x minus 20. Subtract 60 from both sides. Remember we can't have nothing over here, so that means we also have to add 20 to both sides. So those cancel out, and we are left with 20x is equal to 20. Divide both sides by 20, and we get that x is equal to 1. Alright, that is it. That is our last video for section or unit 6. That was section 4. Thank you for watching. I know it, and now you know it.